So guys, in the homework, I assigned to you page 409, numbers 10, 11, and 12. It's just that I didn't have time to discuss this with you, but still I'm assigning this to you. Just read example number 7 on page 389, because it is an example where we find the formula, possible formula for a polynomial given a graph. Okay, page 389, number 7. Try to look at it. Okay, what I'm gonna do now is I'm gonna go through problems 8 and 9 with you here, and hopefully you're gonna get it, and you will be able to do numbers 10 and 11. Now number 12 is a little bit challenging because there might be a need to do some transformation, some translation on this, because the points are not on the axis. So 12 is a little challenging, but you can always try it, and we'll give you credit for it. Okay, so I'll start with problem number 8 on page 409. This is page 409. Okay, so in problem number 8, you can see that the graph, I'll just do a, although this graph is in your book, but I'll just do a quick sketch here. So you have this point, you have this point, you have this point, you have these 3 points here. Okay, so this point here is at -1 on the x. This point is at 1, and this is -1. Okay, so looking at this graph, you can see that it's gonna be cubic, right? Regarding just by looking at the shape of the graph, you can see that it is going to be a cubic equation. So the highest power is 3, and there's going to be 3 roots. So as I can see there, on the x-axis I see a -1, 0, so that gives me 1 root. Okay, so these are the roots or the zeros that I see: -1 and +1. Okay, -1 and +1. So okay, we are given another point. So we are given a point which is 0, -1. So this point right here is the other given point. It's not a 0, it's not a root, it's not a 0, but it's a given point, a point that is on our graph. Okay, another observation we can see here is that it doesn't cross +1, rather it bounces here. It bounces on +1. So that would mean, since it bounces on 1, that means this root 1 will have a multiplicity of 2. Multiplicity of 2. So that makes it 3 zeros here, right? So 1 appears twice, and then a -1. Okay, so now if you have read example 7, you will know that the way we set this up is this. So first we set up the equation. Let's say p of x. Oh, is this p? No, this is f. Okay, they use f for this one. So to be consistent, let's just use f. So f of x is equal to, okay, I'm gonna have a constant k here, which I'm gonna get later on by using the point that they gave me, this k. Now this k will indicate if this k is positive or negative, would determine the shape of my graph. And if this k is a number other than 1, then that will also tell me whether my graph will be stretched or compressed. Okay, so now let's write down the zeros. So for the -1, my factor here will be x plus 1. Why x plus 1? Because if I equate this x plus 1 to 0, I'm going to get x minus 1, which is one of my zeros here, right? Okay, so it's like we're working backwards. If this is if this is the factor, if this is a factor of my polynomial, then I equate this to 0. I do -1 minus 1, I'm going to get x equals -1, and that is my root, which I see here, right? Okay, so let's erase that part. The other one is x minus 1. I set it up as x minus 1 because when I equate that to 0, that would be x equals 1, which is my other root, my other 0, which I see in the graph. Now, since my graph bounces on that point, this has multiplicity 2, okay? The exponent will be even, okay? So now, I'm ready to find the value of k. So to find the value of k, I'm going to use the given point that I have. My given point is 0, -1, so x here is 0, and y is -1. So I'm going to replace my f of x, which is my y, as -1. Then I put k there. Now I'm going to replace x by 0, so 0 plus 1, and then 0 minus 1 squared. So I get -1 equals, okay, 0 plus 1 is 1, -1 squared is 1, so this is 1k. Therefore, my k is -1. Okay, so now I know my k is -1, so therefore, I'm going to write my equation now. F of x equals negative x plus 1, x minus 1 squared. Okay, at this point, you can now try graphing this and try to see if it resembles, if the graph that you see resembles that graph that's given in the problem. Okay, this way of writing the equation is acceptable, but sometimes it might appear as in simplified form, like you just distribute that, you just expand the x minus 1, and you will come up with another form of the equation. Okay, this is the factored form of the equation. Okay, now let's do number 9. Let's do number 9. So number 9 goes like this. You have a graph. I'll try to make a sketch here that, okay, you have a -2 here, and then a +2 here, and you have a 0.11. This is g of x, by the way, they name it g of x. Okay, there's a 0.11 on this part here. Okay. Okay, that's a 0.11 right there. Then I'll try to draw the graph. Goes up, down to the 0. Okay, goes up, down on the 0. Goes up here, and then goes down again. Okay, my graph doesn't look so nice, but anyway, you can see it from the book, right? You can see it from the book. Okay, so now I see 3 zeros, one at -2, one at +2, and one at 0. Okay, and since it bounces on the 0, it bounces right here, so I know that that's gonna be second power. Okay, that root is gonna be, there's a multiplicity of 2 there. Okay, so let's write our equation. So tentative form of our equation will be this. There's a k, and then x plus 2, because that gives me x equals -2 as the root, and then x minus 0, and it has multiplicity 2 because our graph bounces there, it doesn't cross, and then x minus 2. This is the factor that gives us x equals 2 when we equate it to 0. Okay, so let's try simplifying it. Okay, I'm going to write x squared first. Okay, x squared, x plus 2, x minus 2. Now, in order to get, this point is 1, 1, right? In order to get the k, we usually use the point that they give you. So here in this problem, our given point has coordinates 1, 1. Okay, our point that they gave us has coordinates 1, 1. So your x there is 1, your y is 1. Okay, let's plug them in. So g of x, which is our y, is 1. Okay, our x is 1, so this is 1 squared. 1 plus 2, that's going to be 3. 1 minus 2, that's going to be negative 1. Okay. Okay. Plug in the 1 to the x and then plug in 1 to the y. So this gives us 1 equals, okay, 1 squared is 1 times 3 equals 3. 3 times negative 1, so this is negative 3k. And so our k is negative 1/3. Okay. So now I'm ready to write the equation. My g of x, I'm going to write the equation right here. It's negative 1/3 x squared. Okay, let me write down the x squared first. You can also write the x squared as x minus 0 squared, but when you simplify that, it's just x squared. And then x plus 2, then x minus 2. Okay? Or you can write it this way. Negative 1/3 x squared minus 4. Right? Because the x plus 2 times x minus 2 is x squared minus 4. And you can simplify it further. But anyway, this form is already acceptable as the equation of your graph. Okay, now at this point, go ahead and try that out. Like graph that. Use the windows that you see in the problem in the book. They gave you the graph and you can see the window there, and then put in this equation and try to see if it resembles that. Okay, now for number 10, I'll give you some tips on number 10, right? How many zeros do we see there? I see a negative 2. So for number 10, just some hints. For the zeros, I see a negative 2, I see a negative 1, I see a positive 1, and I see a 3. Okay? Now, between these 4 roots, this one is the part where our graph bounces. So this is going to have a power 2. So you're going to write this as x minus 1 squared, right? And then the 3 will be x minus 3, the minus 1 will be x plus 1, the minus 2 will be x plus 2, right? Okay, go ahead, try that out. To find your k, you have to take note that they gave you a point 2, negative 1, okay? So you can also see that this is going to be quintic equation, a quintic polynomial, right? Because there's 5 zeros. Okay, number 11, so the power is going to be 5. Okay, number 11, this is going to be quartic. I see a 0 odd negative 4 bounces, so this has multiplicity 2, right? Multiplicity 2. There's another root which is 3, and again multiplicity is 2 because our graph bounces there. So that gives you like 4 roots, right? And they give you a point, The point that they gave us this time is 0, 4. So remember, you're going to use the point, the given point, to find the k in the equation. Okay? Now, so what I told you, number 12 is a little challenging because those points, -1, 2, 4, -1, 4, 2, 4, 4, 4, they're not on the x-axis. So what you do is like you move them all down. It's like a translation going down so that they will be on the x-axis, or you move the x-axis up so they will all be on the x-axis. So it's a little tricky, but you can always try, and if you can find another way, then that would be awesome too. You can present it to the class on Monday. Okay? Okay. If you have any questions, just email me for anything or any of the mentors. Okay, guys? See you Monday. Bye.